Hello everyone, welcome to Learn Overflow. In this video, we will discuss another LeetCode problem. There is a orderly queue. This is a hard type problem and we'll understand how you can find a solution to this much easier. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says we are given a string s and an integer k. So those are two things given to us and we can choose one of the first k letters of s and append it to the end of the string. Simply means okay, let's understand this. Say there's a b a a c a. Okay, so what we can do is like from the first, like k equal to 3, so that means from the first three letters we can choose any letter and append it at the last. Okay, so just because b was the biggest, so we took it and appended it at the last. Okay, that's the first move. Fine. And then you can see what we did. Then the letters became a c AB. So the first three was AAC. From the first three, we took C and appended at the last. So the final result become like this. Okay. So that's the main, like from the first K letters of S, and like we can choose one of the first K letters. So one letter from the first K letters and append it at the last. Okay. And finally, what you need to do, you need to return the lexicographically smallest string you can have after like applying the mentioned step in any number of moves. So remember, there's any number of moves possible. So you can apply this, take one element and add it in the last any number of times. Okay, there's nothing in it. So we finally need to return it as a lexicographically smaller string. So that's the basic idea. Now let's understand what are the things we need to do. Okay, say when key equals 1, that time what can happen. Say let's take this example CBA, right? CBA. So that's an example for us. Now see what will happen if so that means from the first one letter we can move it to the last, right? So if we move C to the last, then we be left with B, A, and then C, right? That's what we will get after moving it to the last. And then again, if we move the first letter, then at the last, then what will happen? It will be A, then C, and then B, right? But again, if we move A, then to the last, then we'll be ending up over here. Fine. Now, see, this basically means so whatever build string we have, we can actually move one letter at the time towards the end, and we need to find out which one is like giving us the smallest value. Okay, which one is giving us like the lesser lexicographically smallest string. Okay, as the string starting with B, then A, then C isn't smallest than this one A C B, because A being the first becomes a much smaller value. Fine. So you cannot interchange any positions. They are like the normal necklace kind of things. Okay, and each of the beads are there. So you are just making sure like which positions you want to take as a start. Okay, so that's how it is. That's how it is. You cannot change any position for k equal to 1, right? So you just can interchange them and can find out which one having a lower value or which one is giving us a smaller value, right? Now, what can be the other cases? The other cases like k, just nothing says like k will only be 1. There can be k equal to 3 or other values. So let's look at a condition where k equal to 2. Okay. Now, when k equal to 2 and say we have a same string like CAB, okay, which is CBA. Okay, so if we have the same string BA, now see what we can do with it. Now, out of these two characters, we can move one character to the end. Okay, now out of C and B, what if we think like, okay, let's move B to the end. Okay, we moved B to the end. That then out of the first two characters, we can move any character to the end. Okay, so let's move C to the end. The first character is C. So you'll find out like A, B, C. Now, out of the first two characters, do we need to move any other character to the end? No, because we are like by seeing we know, like just by the visual approach, we know that we have the smallest string, like lexicographically smallest string, right? Now, what's this way? Like how we can do it? See, we can do it any number of times. It mentions us like we can make any number of moves. right? So there's no binding with the number of moves. Now, in this case, you will find out, like, you will actually realize that if on a larger string, anything, this will be like whatever be the smallest permutation, the smallest string is actually sorting the all the characters character by character. It can be anything, okay? So it's more like, and it's more like k greater than equal to 2. Fine. This observation will be valid. How? Say like k equal to 3 was there. Fine. So out of CBA, what would you have chosen to take it at the last? So B would have, you would have chosen take it at the last, because uh, doing that we can actually reduce the length to and come down to this. Like if we move B first and then we move C, then we'll reach a value like this, right? So that will be the smallest value for us. So this is the process what we will follow to reach our results. But how we can do that easily? I mean, doing it like stereotypically one by one moving is not an easy task, because we can take off any character, right? So to do that in a proper manner, we will see that uh, simply sorting it will result us in a much easier solution. Okay, actually, when k greater than equal to 2, we can prove that we can use the first two elements as a buffer, okay, for like as a buffer to swap any two adjacent characters. Fine. Now, since we can reach any permutation by swapping the adjacent characters, it is like in this case is the minimal reachable permutation is like the sorted, like the sorted of the string S. Fine. That's the basic idea, because like first two characters, I mean, when k greater than equal to 2, so like first two characters or first three characters, okay, those whatever the k value is. So we can use them as a buffer to just sort the element. It's like more like this bubble sort. Okay, you are just sorting those elements. So we can do that. So like what it I mean is, say we have CBA, right? So CBA is like what we can do. We are doing like if you have k greater than like k equal to 2, see what we're doing, we're just taking B to the end and then C to the end. So actually what happened, this is sorted. Now if we simply take A to the end just for observation, see the values will be B, C, A. Now look at the first two characters. These are actually sorted to the one initially given, the first two characters, right? So that's what I mean. Like when we have something like k greater than equal to 2, we can have the first k characters or first two characters, anything, as like a buffer to swap like any two adjacent characters. We can swap any two adjacent characters similar to the bubble sort. Okay, so in that case, we can actually like the shortest one by the minimal reachable permutation will be the sorted of like the sorted version of that string S. Okay, so that's the basic observation. Now, I hope it's clear how we can go ahead with that. So if I just quickly write down a code, then it will be much easier to understand. So why don't we quickly write this code for k greater than equal to 2, we'll sort it and return. And for k equal to 1, we have to only one option is like keep checking, keep moving character to character at the end, okay, and find out which one resulting in a smaller character. Like you cannot do anything when k equal to 1. We need to check one by one character at the end and find out. Fine. But obviously, there's a small improvement we can do in that approach. So first, let's quickly write this character by character approach, where we character by character check which one is the minimal and then move forward with that. So let's quickly go ahead with that. So this is like the approach we get over here. So for k greater than 1, like greater than equal to 2 or greater than 1, when this k is not 1, then we simply sort it and return a new string out of that. Fine. First we convert it to a character array and then sort the array and then return it. Fine. Else in other approach is like when k is equal to 1, what we're doing, we are like resultant string is like exactly equal to the initial string. That's why initializing, and then we are doing from each of the character. Okay, from length I equal to 1 to s dot length, and we are taking what, say first of all we are taking s dot substring I. So that means from ith position till the end, all the values we are taking, and then we're like how I'm moving the character to the end is more like s dot substring 0 to I. Like remember, this is 0 to I is like less than I. So 0 to I, we are moving it to the end, and then simply we are considering the I to the end as the first character and moving the 0 to I as the end. Fine. So this is what we're doing, and then we're simply checking like if our resultant dot compared to our temp. So this is a temp we created. Okay. If it is greater than 0, that is somehow we find that the value is reducing. So we will say resultant is temp. Okay. Anywhere we find the value is reducing, we will say resultant is temp. Okay. Now, finally, after we are done with all the checks, we will return the result. The result. So this is the normal approach. So as you saw, like I just submitted it. So as you saw, this is like 3 MS solution. Okay, and obviously, it varies at times. But if you think like, can we improve this? Improve this in a way you cannot improve it further because you can say like 2 MS is actually the highest solution you can reach, like the fastest solution. So what can kind of improvement you can bring it here? See, again and again, doing a substring cost your time. You need to understand that whenever you're doing substring again and again and again, so substring takes a huge amount of time. Okay, so how you can improve this is like you may like what will happen if you need to like do 2 3 print statement within this, and you need to find out what is the exact case when this temp is getting changed. I mean, when this is the resultant is getting changed. Okay, so if you look into that, you will find that it's like one or two. Like actually, if you find that once is the case when this resultant is getting changed. Fine. How I can say that is simply because if you see whatever be the smallest character we have in our like we have in our character like a string, so best of the smallest character you will find that this change is result in the smallest. How? Let me say it's like we have k equal to 1, right? So for k equal to 1 we don't have anything other than that. So what we can have is like, say we have C, B, A, right? So we have this character, and then we need to find out like if we have tried to approach like this, that C equal to like what is the minimum character we can find? Minimum character, like minimum character is like A, fine. So we can find the minimum character as A, fine, and then from this minimum character, okay, take this minimum character at the front and rest all of the character as it is at the end. So what will happen? So it will result in A, C, B. So isn't it a result that we are looking for, right? So whatever the minimum character is, take that minimum character in the front and then take all the characters as it is. Fine. So if in that case, we'll find that the value will reduce. Now you may say that A can be repeated many times. Yes, that's definitely true. So in that case, what you are doing, you are just like you are doing like taking all the A in the beginning and all other elements at the end as it is. So that's what the approach you can try out. So that's the kind of approach I like did with this other case, like the when I got this MS2 to MS. So I'll just put that kind of approach in the like the in the discuss section. The link will be there in the description. You can try out that approach. That's not reducing too much of time, but I feel that's kind of an reducing a bit of time. Okay. So as it is, that approach will also be order of n. For this approach, you can see something over here. Okay, you can find out that for this particular approach, what we have in this case is like for array, like as just sort, we know it's n log n, right? So, it's n log n, and for each tree, we here over here we are traversing. So we're checking whether like we are traversing this as order of n, and with that, remember this is like compares to is also takes an order of n time. So like it's like whenever we're checking for the smallest and or not, it's again taking an n time for us. So it's like order of n square is the complexity we have over here, and over here and log n. So you know that the highest complexity is order of n square. So it will remain as n square. So you cannot remove reduce further. So that remains the same more or less. Fine. So I hope I can make you understand how you can solve this question. And if you have any doubts, make sure to comment them down. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video. Thank you.